Question 7. Now this requires a specific skill set which you need to really have practiced before going into the test. But here's how to do it, so hopefully you'll know if this comes up again. Now I don't really like sketching derivatives on the same axes. I don't think that really makes sense, but sometimes they might ask you to do that, so and they did here, so let's just crack on. Now if you were asked to describe the derivative or describe the gradient of that blue function, you'd probably say it's constant negative gradient, and you can actually work out that it is constant minus a quarter, because we know it passes through the origin and that point indicated there. So it's got gradient minus a quarter for all values of x. So you're drawing a function that has value minus a quarter for all values of x. There it is. It's a straight line, it's a constant minus a quarter for all values of x. It's a gradient function you're sketching. Okay, that's one mark. Part B. You're looking at a quadratic. Quadratics tend to differentiate to linear. It might not be a quadratic, but it gives you a bit of a way in if you think of it as a quadratic. So it's probably going to be a straight line that we end up drawing, isn't it? Because when you differentiate a quadratic, that's what you get. So we just need to think about a couple of features of this curve. It has, sorry, I've just shown the answer. It has gradient 0 at x is 2. So here it's going to be 0. Here our red function is going to have value 0. Here the gradient is large and positive. So our red function is going to be large and high. But it's coming down and down and down, still positive gradient, down and down and down to 0, and then slightly negative gradient, and then getting more and more and more negative as we go this way. And as I've already revealed to you, there's our straight line. Starts positive, but gets shallower, down to 0 gradient, and then goes into negative gradient territory and keeps getting more negative from there. Part C, well, good to spot that we're looking at what appears to be a cubic, so it's probably going to differentiate to something that looks like a quadratic curve. And again, we just need to look at a couple of features of this curve. So notice where the gradient is 0. The gradient is 0 at those points, so our red gradient function is going to have the value 0 at those points. And if you know you're going to draw a quadratic, you can probably just go ahead and draw it now, but we just need to get it the right way round. Notice that between the two values we've got negative gradient. So our red function is going to have to come down here underneath, and you can visualize it now. We've got large positive numbers here, gradients, 0 gradient, negative gradient, 0 gradient, positive gradient, and we're looking at something that looks like that, therefore. It might be shallower, but you'd get the marks for identifying that it would be a quadratic passing through those 2 points on the axis.